Hello बच्चों, सत श्री अकाल and namaste from my side. How are you all? So, this is your own physics educator Indrajit Singh welcoming you all into the most senseful platform. Right? Most senseful platform. So, this is PW Gulf, and today we are going to move forward to the current electricity. As a long discussion went on with the team, we were having the very less amount of the time and we have to discuss more. So what I did like, let's take a questions, whether it should be the PYQs or it should be the another type. Through questions we are going to explain the theory, right? Through questions we are going to explain the theory, else the lectures would be quite long. It will take 2.5 hours, 3 hours, because beyond this one new series is going to come. Okay, beyond this a new series is going to come. Okay, I think they will plan that about the detailing lecture. Okay, so for this lecture, okay, for this we will keep some of the limitations that we are going to discuss the question. We will follow the reverse engineering. Through discussing the question, we will follow the concept. Through discussing the numerical, we will follow the concept. Okay, the numerical can be any PYQ or any practice question, right? So today we are going to see the current electricity because it is only the way to cover the maximum part into the shortest amount of the time, and you will also have the glimpse of it, right? So guys, I think without wasting our time, first of all, let's keep this aside. Okay, without wasting our time, let's move on to the specific content. So what we are going to do, the agenda of today's lecture will be current electricity, right? Agenda of today's lecture is current electricity, questions through concept, or you can say concepts through questions. Right? Okay, so let's move on to it. Right? First question. The question that was asked in NEET October 2020 amidst the pandemic. Right now, you also, where you might be heard or you might be hearing from your near ones that rise of the COVID cases. A new variant has came into the market. Okay, the new variants of COVID, right, are coming faster than the mobile phones, the smartphones. Okay, generally a year back, still now also, right, we are having a habit. Now this phone is going to launch. Have the okay. The fastest phone launch comes from the iPhone and some companies. Okay, but this COVID is ahead of all. Okay, again the new virus came up into the market. You don't have to purchase it. Okay, it has came just to aware you all that you have to be away from it, following the measures to protect yourself. Okay, because COVID cases are rising into the India. Okay, now we have reached to 6,000. Okay, let's move on. Two solid conductors are made up of same material, have same length and same resistances. Two solid conductors are there. They are made up of the same material, right? One of them has a circular cross section A1, another has the square cross section. Okay, see, one is having the circular cross section A1, another it is having the square cross section, right? Okay, one is having the circular cross section, second it is having the right square cross section. Now within both this stuff, right, they both are made up of the same material, they are made up of the same length. So these are the cross section. Okay, this might be made up of like this way. Okay, and this made up of I'm sorry to have this. Okay, it is important to determine, right, how they are made up of, because without that you are not able to understand, okay, the variety of the question. Okay, so this is a cross section A2. Okay, this is a cross section A1. Both are having the same length. See, both are made up of the same material, right? Same length, same material and same length. Okay, so here one of the cross section of the circular A1 and another of the cross section A2. We need to calculate the ratios of A1 is to A2. We need to calculate the ratios of A1 is to A2. Okay, we need to calculate the ratios of the area. Okay, we need to calculate the ratios of the specific area. Yes or no, guys? Okay, so I think without wasting our time, a very nice question it is. I'm going to give you all a minute to solve this stuff. Come on. Okay, so whatsoever the answer comes up, I will be waiting for all of your answers. Okay, come on everyone. Practically speaking, we don't have to move on to that much data, right? The question states that, right? The question states that same material, same length, same data. Same material, same length and same resistance. These are the three key points that will help you all, right, in understanding the stuff, what kind of formula you are going to use. Same material, same length. Okay, so let's see. Geometric structures are involved, so we are going to use the formula of the resistance, as you all know. Okay, in case of the geometric structures are involved, we are going to use the formula like R is equal to rho L by A. Okay, for the first resistances, if I am using up the formula of area, that is rho L by R. For the first material, area will be A1 is equal to rho 1 L1 by R1. For second material, that is rho 2 L2 by R2. Can I consider this as equation number 1? Can I consider this as equation number 2? Right? On taking ratios of 1 and 2. Okay, on taking ratios of 1 and 2. So, it can be defined as A1 by A2, that will be equivalent to what? Right? Everything is same only. Right? Everything is same only. Material is same, rho will be same, length is same, resistance are same, right? Each and every keyword that is mentioned into the specific question. Okay, each and every keyword is mentioned into the specific question. So what will be the ratios of the areas? The ratios of the areas will be 1. The second is the perfect answer for the specific question. Second is the perfect answer for the specific question. Yes or no, guys? Right? So see how awesome they are playing with you all. How easy some they have asked in NEET 2020. By the way, practically speaking, it was amidst the pandemic. Okay, when the first wave was at the peak and the NEET examination appeared, we were in the midst of the lockdown. Okay, no one is able to move out of the home and blah blah blah. Right, we were aware of this stuff, but we weren't aware of this stuff. Okay, everyone was into the hustle and bustle of gathering the food for the right fulfilling the full food storage right into your houses. Okay, so at that time there was a possibility, and amidst the pandemic they went bit liberal with you all, but this is not a thing that is going on all the time. Okay, this is not a thing that is going to on all the time. So I'm going to give you all 10 seconds approximately if you want to just note this down, else we can move forward to the next sum. Come on everyone, on the countdown of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's move on to the next question. The next question, right? NEET September 2020. Okay. Again, amidst this pandemic, amidst the first wave. At that time, an issue went on, right? As because of that, the two NEETs were conducted. Okay. The question is based on the color code of a resistance is given below. Color code of carbon resistor is given below. The values of the resistance and the tolerance respectively are. The values of the resistance and the tolerance respectively are. Everyone knows for the color code of the carbon resistor, we are having a specific table that we need to follow. We have a specific table that need to follow. From that table only, we have to retrieve all of those data and find out the values of the resistance. The color code of carbon resistor is the method to identify the value of the resistances for the physical materials into an industries. Okay. The material that has been given physically to the peoples, right? On that case, how the person is able to identify its resistance value. For that, the color code of carbon resistors is used, right? So come on everyone, the table is huge. I'm going to give you all 2 minutes to solve this stuff. Come on fast everyone. Okay, and then we are going to see the table and the respective detailed solution. Okay. See, for the color code of the carbon resistors, right, we need to follow this table. Okay. Now it starts with it starts with BB Roy. GB, actually I used to write it like BB Roy, right? GBV GWGS. Okay, some used to make up those stories as the some went to BB Roy went to the Great Britain, like that way. BB Roy, BB Roy, GBV, GWGS. BB Roy, GBV, GWGS. Yes or no? Right? Okay. This isn't going to be quite hard to remember, practically speaking. This is not going to hard, right, to remember, but this is only the stuff that going to, right, fix you all into the mess. Okay. So BB Roy, GBV, GWGS. Right. Now, how we are going to solve this stuff? Come on. Let's check it out. What kind of the resist? The first band is the yellow band. Right. Okay. The first band is the yellow band. So for yellow band, okay, the first digit would be, see, all the time into the resistors we are having the 4 bands. The first band represents the first digit of the resistance value. The second band represents the second digit of the resistance value. The third band represents the multiplier, and the fourth band represents the tolerance value. Right. Again I am repeating, 4 bands on the resistor. Okay, this is a physical resistor that is always kept to the people, right, is given to the people so that they can identify, right, the value from it. First band, first color band, first digit of the resistor. Second color band, second digit of the resistor. Third color band, multiplier. Fourth color band is a tolerance value. So the first is going to come upon as 4. Okay, the first one is 4. Okay, the second band is violet, right? Violet, it means it is 7. The third band is brown. In multiplier we are having the brown as 0, right? Okay, so okay, I think it is 0. And what will be the tolerance value? Plus or minus 1%, right? Plus or minus 1%. I think some printing error is there. Okay, sorry, it is gold. I heartily apologize, it is gold. Okay, gold is having plus or minus 5. Okay, so this band is gold, the fourth band is gold, right, and it is having plus or minus 5%, right? Okay, and the brown is having 10 to the power 1, right? So it means 10 to the power 1. So the third band, it is going to be brown. Okay, so it is 10 to the power 1. So what will be our answer? 47 into 10 to the power 1 plus or minus 5%. Okay, so this is going to be the resistance value going to be 470 ohm plus or minus 5%. Okay, okay, 470 ohm plus or minus 5%. The C is going to be the perfect answer for this specific question. C is going to be perfect answer for the specific question. Okay, so if you want to just note this down, you can. With this, I am going to give you all some resistance values as a question, right, as a homework that you have to answer, right, okay, within the comment box below. Okay, so on the countdown of 10 seconds, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now I'm going to give you all some resistance values, right, as an homework that you need to, right, evaluate. Okay, this will help you all because it is having the highest possibility to come up into an examination. Okay, 4 questions I am going to give you all. Okay, now we are about to complete. Okay, and when we need one more. So I think, okay, just hold on. Let's keep it here. Okay, so guys, this is all the homework from my side. Okay, you have to answer all of those values for all of those resistors, number 1, number 2, number 3 and number 4. You have to answer all of those resistors beneath the video using the technique of color code of carbon resistors, right? Using the technique of color code of carbon resistors. Yes or no, guys? Okay, yes or no? Okay, so we just note this down. It will be available into the notes also. Okay, so let's move on to the next question. Again, it was asked in the NEET October 2020. I told you all. Okay, I came upon with the very nearest questions, right? This time we have to calculate the equivalent resistance between A and B for the mesh shown into the figure will be what? I think it is not as hard as what we are thinking. Practically speaking, it is not as much hard as what we are thinking. We just need to find the equivalent resistance between A and B, right? So it means that we need to calculate the equivalent resistance between A and B. Okay, so let's give you all a time to solve this stuff. Come on everyone, fast, right? I'm giving you all, right, you all should have a habit to solve all of those stuff within small period of time, guys. Okay, I think we need to draw this circuit here to solve this question effectively. Right? Okay, this is going to be 4 ohm. This is going to be 8 ohm. Okay, this is going to be 6 ohm. Okay, for the people of 2020, this question is going to be disguised. Right? It is going to be the blessings for all. Why? If this kind of the question should come up into the NEET, and immediately within 15 seconds you can solve this stuff. Dhar, 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 dhar. Right? See guys, these two are in series. Okay. So can I replace all of those two resistors with a single one? Okay, I'm going to redraw the entire circuit within here only, and I'm going to solve the stuff. Right? So if these two resistors are in series, then equivalent it would be 8 plus 4, and that would be equivalent to 12 ohm. equivalent would be 8 plus 4 and that is equal to 12 ohm. So can I replace both of the stuffs by single resistor? Can I replace it or not? Okay. So 8 and 4 will become 12 ohm. Okay. 8 and 4 we are going to, it is going to be 12 ohm. Now 12 and 6 they are in parallel. 12 and 6 they both are going to be in parallel, right? Parallel, it means that equivalent resistance would be 12.6 whole divided by 18, 6 3s are 3 4s are, it is going to be 4 ohm. Okay, it is going to be 4 ohm. So can I replace both of these two resistors, right, by the single resistor value? Okay, can we replace both of the two resistor by the single resistor value, and that resistor value will be nothing else but the 4 ohm, right? Okay, now what happens? 8 ohm, 4 ohm and 4 ohm, they all are in series, right? 8 ohm, 4 ohm, right, they all are in series. Okay, so the equivalent resistance between A and B, right, it is going to be 16 ohm. Equivalent resistance between A and B, it is going to be 16 ohm. Okay, so what is the perfect answer? 16 ohm is the perfect answer for this specific question. Okay, 16 ohm is the perfect answer for this specific question. Yes or no, guys? Is it cool? Okay, step by step we have solved and redraw the circuit here only. Okay, step by step we have redrawn the circuit and solved that sum here only. Okay, so I'm moving aside on the countdown of 10 seconds. If you want to just note this down, you can. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's move on to the next question. Okay, NEET National 2019. In the circuits shown below, the readings of the voltmeter and ammeters will be. Okay, the readings of the voltmeter and ammeter will be. The two circuits are shown. Okay, and options are given like V1 would be equivalent to V2, I1 would be equivalent to I2, I1 would be greater than I2. Okay, so here the voltmeter reading is V1, the current flowing is I1. Here the voltmeter reading is V2 and current flowing is I2. Right, so using the actual concept, we need to find the correct relation between V1 and V2, I1 and Y2. Okay, we need to find the correct relation between V1 and V2 and I1 and I2. Okay, come on everyone, I'm going to give you all some amount of the time to solve this stuff fast. I'm sorry for that. Again, I'm going to repeat. No word ideal is used within it. No word ideal is used within it. There is a difference between the ideal voltmeter and voltmeter. There is a difference between the ideal ammeter and the ammeter. Okay. There is a difference between the ideal voltmeter and voltmeter, and there is a huge difference between the ideal ammeter and the ammeter. The ideal voltmeter is having the infinite resistance. Okay. The voltmeter is not having the infinite resistance. There is some value of R. If the voltmeter is not ideal, it is going to draw some value from the supply. Into the case of the ideal voltmeter, only terminal voltages are given to the circuit. Right? Some of the voltage from the supply, right, gets drawn. In case of the ideal, right, ammeter, resistance is 0. But in case of the ammeter, resistance is not 0. It draws some current. It consumes some current from the circuit. Okay, this is the important thing that you all need to understand. Okay, without understanding this difference, you are going to create a mess. And again, one word, if something is not written into the question, then you have to consider all voltmeters and this ammeters as ideal. Now I'm going to show you all one difference. See, okay, let's take this example only. Okay, into the first circuit, the 10 ohm resistor is connected to the 10 supply. Okay, into the first circuit, let's take it. This is a supply given to the circuit. Okay, this is a current ammeter reading and this is a voltmeter reading. Okay, ammeter and voltmeter. This is a 10 supply and this is the 10 ohm. Now what happens? Right? Okay. Now what happens? See, practically speaking, this voltmeter, if I am considering the ID as ideal, right, then whatever the supply it is given, all of those the resistor will get. So that is 10 by 10, that is equal to 1 ampere. If voltmeter is ideal, then 1 ampere current flows through the specific circuit. Voltmeter is ideal, then 1 ampere current flows through the specific circuit. Ammeter is ideal, it means that resistance is 0, here resistance is infinite. Into the lower branch, if resistance is infinite, then in this branch current will be 0. If in this branch current will be 0, then voltmeter is going to measure the actual value without any errors. It is going to measure the actual value without any errors. But this happens only into the case of the ideal voltmeters and ammeters, right? So here V1 it is going to be 10 volt, right? And I1 it is going to be 1 ampere. Okay. Now into the second case, what happens? Okay. Into the second case, two resistors are there. Okay. We are having another resistor into the parallel connection. Right, we are having another resistor into the parallel connection. Okay, and this is a 10 volt. Now, whenever the two resistors are connected into the parallel, both of the resistor are going to have the equal voltages. It means the upper branch is also going to have 10 volt, the lower one will also have 10 volt. Upper one is also going to have 10 volt, but into the case of the ideal voltmeters, into the case of the ideal voltmeters, right? Okay. Again here also, the value of the V1 into the circuit. Now suppose this is providing the infinite resistance. Okay, suppose this branch is providing the infinite resistance. Again, the upper branch will only be active. So I2 will be again 10 by 10, that will be equivalent to 1 ampere. Okay, and the reading of the voltmeter is again 10 voltages. So from both of these cases, V1 and V2 values are equal, and I1 and I2 values are also equal, right? So both of the cases, right, V1 and V2 values are also equal, and I1 and I2 values are also equal, right? Yes or no? So simply speaking, right, this is a case of ideal, that's why both values are being equal, right? This is a case of the ideal, then both of the values are, right, equal. And second is the perfect answer for this specific question. Okay, second is the perfect answer for the specific question. If you want to just note this down, you can, on the countdown of 10 seconds, right? I think this you want to note it down. 10. You can just pause this video so that we can move forward to the next question. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's it. Let's move on to the next question, right, to solve this stuff. Again, NEET September 2020. A charged particle that is having the drift velocity 7.5 into 10 to the power minus 4 meter per second. Drift velocity 7.5 into 10 to the power minus 4 meter per second, right, into an electric field. Electric field is 3 into 10 to the power minus 10 volt per meter. Okay, electric field value is this, has a mobility of, very nice question, very easy question. We need to calculate the mobility of the charge carriers, right? We need to calculate the mobility of the charge carriers. Yes or no? Right? So giving you all amount of the time, and the countdown of 1 minute. Come on fast. Okay. See, solution to the question is quite simple. Right? Solution to the specific question would be quite simple. The reason behind it is the mobility of the drift charge carriers. Okay, mobility of the drift charge carriers. Okay, See what happens here, practically speaking. Okay, what happens here? Formula of the drift velocity array, the mobility is drift velocity per unit of electric field. Okay, you are aware of the theory, you are aware of what actual the mobility of the charge carrier is all about, what actual the mobility is all about. Okay, you are aware of this stuff. So directly if you are going to calculate right the mobility, okay, then it is defined as, okay, let's replace those value, that the drift velocity is 7.5 into 10 to the power minus 4 whole divided by 3 into 10 to the power minus 10. Okay, so mobility it would be into 10 to the power 6. Okay, 2.5 into 10 to the nearby equivalent to 2.5 into 10 to the power 6. The second is the perfect answer for this specific question, right? Second is the perfect answer for this specific question. Okay, on the countdown of 10 seconds, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, yes or no? Might have paused this video. NEET 2017, as I promised, see very nearer questions I have brought. The resistance of the wire is R ohm. Okay, see, there is one resistance, there is one wire whose resistance is R ohm. Okay, initially this is the situation. Now what happens if it is melted and stretched on n time its original length? Suppose this is melted and stretched to n times the original length. Suppose initial length was L, it is melted and now stretched to n times the original length, right? Now the new resistance of the wire will be what? Okay, new resistance of the wire will be what? A very awesome question, but you need to think it off, right? Come on everyone, going to give you all some amount of the time fast. whenever this kind of the questions are going to come up into an examination, right? Okay, the questions of stretching, right? Then always keep one thing into the mind. Okay, see here, if they are getting stretched, here the length is L, then the radius is R1. If the length is changing, then with the length, the radius is also changing. Why? Resistance is the value that it depends on the geometry of the object. R is directly proportional to L and R is inversely proportional to area. R is directly proportional to L and R is inversely proportional to area. Right? R is directly proportional to L and R is inversely proportional to area. Okay? Now what happens? Okay, if it is getting stretched, here the students are having a myth. The length changes, what they are going to do? R is directly proportional to L. So R1 by L2 is L1 by L2, right? So R2 is equal to N R1. So they are going to select the first answer. Actually, it is, you are following the wrong approach. Okay, you are approaching it wrong. Okay, this isn't an answer. If it is getting stretched with the length, the radius is also getting changed, and with the radius, area also changes. So whenever it is stretched, right, the volume is always constant. Whatever the changes you are facing, it is in between the length and the radiuses, right? The volume always remains constant. Whatsoever the things that you all are facing, right, it is always between the length and the radiuses. Okay, it is always between the length and the radiuses. Okay, right? So it is always in between the length and the radiuses. So now how we are going to solve this sum? Volume is kept constant. Volume is kept constant. So can I say V1? That would be equivalent to V2. So it is A1 L1, that is equal to A2 L2. So that will be R1 square L1, that is equal to R2 square L2. So R1 by R2, the ratio, it will be under root of L2 by L1. Right? So R1 by R2 ratio, it is going to come upon as, okay, under root of N. Length is changing now. Previously the length was L, now it becomes NL. This is what mentioned into the question. It is stretched to N times its original length. Okay, it is stretched to N times its original length. So R1 by R2, that is going to be under root of N. Now what happens here? R1 by R2, that is going to be under root of N. Now what happens here? See, practically speaking, okay, now R is equivalent to rho L by A. So it means R1 by R2, that is going to be L1 by R1 square into L2 by R2 square. So the ratios of radiuses will be L1 by L2 into R2 square by R1 square. Right? Okay. So this R1 and R2, it is going to be L by NL, that is 1 by N. So this is, sorry, this is going to get cancelled. So R1 by R2 is equal to 1 by N square, right? R2 is equal to N square R. This is the correct approach. This is the correct approach. Yes or no, guys? So you all shouldn't be into the myth. You all shouldn't be into the myth. What kind of a myth? Right? You all shouldn't be into the myth. What kind of a myth? That resistance and length things are always given, then we have to forget radius, right? And we have to follow the previous approach that we did, this one, and select NR, and we say yes, I love physics. After one solving question, I love physics, and if I love physics, tomorrow I'm going to be Newton. So you can be Newton, you can't be Newton. right? You can be Newton, okay? You can't be Newton, okay? So what is the perfect answer? The n square r is the perfect answer for this specific question, okay? N square r is the perfect answer. So this is only the question in the entire session till now that we have reached up to 2017, or else we have moved on to 19, 20, 21, 19, 20, 21, like that way, okay? So if you want to just note this down, you can. I'm going to give you all 10 seconds. You can pause this video and move on for this. Come on everyone, on the countdown of 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's move on to the next question. Okay, now we have came upon NEET 2016. It's a very nice question. The charge following through a resistor of resistance R varies with time as this equation. Charge varies with time as AT minus BT square. AT minus BT square, where A and B are the positive constants. Okay. Charge varies with time as AT and BT minus BT square, where A and B are the positive constant. The total heat produced in R will be what? Okay. So we need to calculate the total heat produced into the resistor. Wow. Okay. But here they are asking like total heat produced into the specific time, right? Okay, total heat produced into the resistor. Okay, very nice question. There is a logic behind it. Okay, that you need to crack it up. Come on, fast everyone. I'm going to give you all 1 minute to solve this stuff. You can judge it out the level in between the 2016 based question, right? And the question coming up from the 2019 and 20. 19 and 20 based questions are quite easy, right? And 16 is gonna be awesome. But whenever we used to move on for 16, 12, 10, 2010, then student always used to say, past 5 to 7 years, must, right? Okay. The charge flowing through the resistor is this. My question to you all, till what amount of the time this charge is going to flow? Till the current is going to be non-zero, charge will flow. When the current will become zero, the flow of charging through the resistor stops. Okay. So after what amount of the time the current is getting zero? The amount of the time current is getting zero is only the amount of the time heat will flow through the resistor. Amount of the time current will be zero, right? Heat stops flowing from resistor, right? heat stops flowing from the resistor. Yes or no? Okay. So in this case, what happens? Q is equal to AT minus BT square. Let's differentiate this dQ by dt, that is equal to I, A minus 2BT. At what time the current is going to be 0? T is equal to A by 2B. At this time, current will be 0, right? Heat flowing through the resistor will stop. Heat flowing through the resistor, it will stop. Yes or no? Okay. And what is the equation of current? That is A minus 2BT. Okay. Now, what is the formula of the heat flowing through the circuit? It is integration of I square R dt. Can we replace those value? H is equal to integration of, right, A minus 2BT whole square into R of dt. Okay. So that is moving on from 0 to time t, and that time will be A by 2B. So H, it is going to be A minus 2BT whole to the power 3 by, or yeah, rather than that, we can directly move on to this. Okay. So this is whole to the power 2 now. You can directly say that this is A square. Okay. Plus 2AB. So it's 4ABT. Right. It would be minus, okay, plus 4 P square T square, right, into R dt. Okay. Integration from 0 to t. So this is going to be A square t minus 2ABT square plus 4 by 3B square t cube, okay, into R. Now we have to replace those values. We have to replace those values, and this would be the last question. Right. Okay. So on replacing all of those values, you are going to get the value of the H as A cube R by 6B. Okay. A cube R by 6B. Okay. The 6 is going to be the perfect answer for the perfect specific question. Okay. This is going to be the perfect answer for the specific. I think lots of calls are coming. So students, thank you. Thanks a lot for your cooperation and time. I think it's time to go, right? It's time to go. Again, we are going to come back soon with the 4th chapter, moving charges and magnetism, right? So this is your own physics educator, Indrajit Singh, signing off from the desk. Bye-bye. Sat Sri Akal and Namaste from my side, Bachai. Bye everyone. Stay at home, stay safe, stay healthy amidst this pandemic, right? And take care.